Now we're going to talk about rational exponents. And here the word rational means like a ratio or a fraction, something over something else. So rational exponents are exponents that are fractions. So we're going to be talking about what it means when you have something to the 1/2 power or to the 2/7 power or something like that. What happens when the exponents are fractions? First, remember from last time when we were talking about radicals, we did some square roots, and we saw that the square root of x squared is x, the square root of x to the 4th is x squared, the square root of x to the 6th is x to the 3rd, and so on. So when we take the square root of x to some power, we get x to half of that power. So taking the square root of something like that would really be the same as taking something like that to the 1/2 power. Because remember, when you take something to a power and then take that to another power, you multiply the exponents together. So x to the 2 power to the 1/2 power would just be x to the 1 power, just x itself. X to the 4th power to the 1/2 power would be x to the 2nd power. X to the 6th power to the 1/2 power would be x to the 3rd power. X to the 8th power to the 1/2 power would be x to the 4th power, and so on. So taking the square root of something and taking that something to the 1/2 power have the same result. And based on that, we just make it a rule that anytime you have something to the 1/2 power, that's the same as the square root of that something. So for example, 100 to the 1/2 power means the square root of 100, which would be 10. Notice that's not the same thing as 100 times the number 1/2. 100 times 1/2 would be 50, but 100 to the 1/2 power is the square root of 100, which is 10. And what if we have other kinds of roots besides square roots, like cube roots or fourth roots? Taking the cube root of x to the 6 is the same as x to the 6 over 3. Taking the fourth root of x to the 40 power is x to the 10 power. And because of that, we make it a rule that anytime we have something to the 1 over n power, the 1/3 power, the 1/4 power, or any fraction that it's 1 over something, that's the same as the nth root of that thing. So for example, 729 to the 1/3 power means the same thing as the 3rd root or cube root of 729. And that turns out to be 9. 1024 to the 1/5 power means the same as the 5th root of 1024. And that turns out to be 4. So in general, anytime you have something to a power that's 1 over something, the denominator of that fraction tells you what kind of root that you're taking. Something to the 1/5 power is the same as the 5th root. Something to the 1/3 power is the same as the cube root, and so on. So some examples. What is 36 to the 1/2 power? Well, it's the same as the square root of 36, which turns out to be 6. You can even do that on a calculator. If I ask my calculator, what is 36 to the power of, in parentheses, 1 divided by 2, so I'm asking it for 36 to the 1/2 power, it does tell me that that is 6. So you can put fractional exponents into your calculator. What's 8 to the 1/3 power? Well, it's the same as the cube root or 3rd root of 8. It's the number that you have to raise to the 3rd power to end up with 8, and that number is 2. The cube root of 8 is 2. What's 81 to the 1/2 power? Same thing as the square root of 81, which is 9. What's negative 1,000 to the 1/3 power? It's the same thing as the third root or cube root of negative 1,000, which is negative 10. What's 16 to the 1/4 power? It's the same as the fourth root of 16, the number that you have to raise to the fourth power, or multiply 4 of that number together to end up with 16, and that number is 2. What's 10x to the 1/5 power? First of all, be careful. The 1/5 power only applies to the x, not to the 10, because powers come before multiplication in the order of operations. So the 10 is just out here minding its own business, and the x to the 1/5 power is the fifth root of x. So this is equivalent to 10 times the fifth root of x. What's 81 to the negative 1/2 power? Okay, so here we have a negative exponent. You remember what happens when you have something to a negative power? It's the same as 1 over that thing to a positive power. So 81 to the negative 1/2 power is equivalent to 1 over 81 to the positive 1/2 power. And we already know what that is. It's the square root of 81, which is 9. So here we get 1 over 9. And what if the power, the exponent, is a fraction that has something other than 1 as its numerator? A to the m over n. Well, that would be the same as a to the 1 over n to the m power. So it would be the nth root to the m power. So if the exponent is a fraction, the denominator of that fraction tells you what kind of root to take, and then the numerator of that fraction tells you what power to raise it to. So for example, the number 1,331 to the 2/3 power is like taking the third root or cube root of 1,331 and then raising that to the 2 or second power. So first of all, the cube root of 1,331 is 11, and then 11 squared is 121. Another example, x to the 4/7 power means the 7th root of x to the 4th power. And it doesn't matter what order you do things in. You can start by taking the 7th root and then take that to the 4th power, or you can start by taking x to the 4th power and then take the 7th root of that. Either way, it comes out the same. Y to the 10 over 2 power is the same as the 2th root, the square root of y to the 10th power. But from what we talked about last time, the square root of y to the 10th power would be y to the 5th power. And since 10 over 2 is just 5, it makes sense that y to the 10 over 2 power would be equal to y to the 5 power. So some more examples. What is 8 to the 2/3 power? Well, you may have noticed I made a typo that I had to go back and fix. 8 to the 1/3 power, that would be the cube root of 8, which would be 2. And then we take 2 to the second power, the number on top is the power we raise it to, and we end up with 4. So 8 to the 2/3 power is 4. 49 to the 3/2 power. So the number on the bottom of that fractional exponent tells you what kind of root to take, the square root of 49. And then the square root of 49 is 7, then we take 7 to the 3rd power. The number on the top of the fractional exponent tells you what power to raise that to. And once we've taken the square root of 49 and gotten 7, 7 to the 3rd power gives us 343. The expression 7x plus 1 to the 2/3 power would be like taking the third root to the second power. We can first take the cube root and then take it to the second power, or we can first take the second power and then take the cube root of that. But either way, it's the cube root of 7x plus 1 to the 2 power. Now, all the rules of exponents still apply. These were covered back in chapter 5, which was before our class, but I did review them briefly in yesterday's video when we were introducing the chapter. So for example, a to the m times a to the n equals a to the m plus n. That still applies even if these exponents are fractions. So all of these exponent rules still work regardless of whether the exponents are positive or negative, whole numbers or fractions. So I'm going to end this video here and come back in part 2 to work through some examples using these exponent rules. See you then.